All right, let's get started. Hello, everyone. Welcome to the last seminar for the fall 2026 semester. Today we have with us Peter Ukhana. He is a principal consultant with the Google's public sector IR team. It's called Mandiant. Before that, Peter also worked extensively in the defense sector for several years, and we look forward to hear from him on exciting things that he want to share today. Peter, please.
All right, thank you for that intro. Good afternoon, everybody. So today I'll be talking a little bit about from MOVEit to EBS. So I'll look at the various mass exploitation and extortion campaigns that we've responded as Google Mandiant over the past couple of years. And in case everybody's wondering, what is MOVEit, what is EBS? Don't worry, I'll talk about the specific products here in the next couple slides and throughout this discussion. So one quick disclaimer for this, during times I might bring up theoretical concepts about, an engagement that we worked for. A lot of that is just pretty much like obfuscated. There's no like, hey, this client was involved. It's just general discussion about what happened kind of thing. So from an agenda perspective, I've got a quick intro, a little bit more about where I used to work. Then we'll talk about CLOP and Fin11. So this is going to be our main entity that we see in a lot of these mass extortion campaigns that have been observed, that they do intrusion. They're the biggest one, but they're not the only one. So in some of them, different entities were involved. And then we'll run through 4 different events that impacted products where somebody exploited them and then exfilled a lot of data, took a bunch of other data, and then attempted to ransom that data back to the clients. So first one being MOVEit, the other one being Snowflake, then Clio, and then finally Oracle EBS. That one has been in the news if you've been seeing the news since approximately end of September, beginning of October. And then we'll briefly talk about some detections and recommendations in terms of how could you have potentially detected this before the threat actor reached out, as well as how to harden these systems. So yeah, as I was introduced, I'm Peter Yukhanov. I work with the Google Public Sector / Mandiant Incident Response team. We are technically the same, but also different. So primarily do incident response inside of government entities, government-affiliated entities, as well as education, state, defense industrial bases, so areas like that. So prior to joining Mandiant almost, I think, over 3 years ago at this point, I used to work at Dragos, where I did incident response also, but there I focused mainly on industrial systems. So think about power plants, water treatment plants, stuff like that. So the thing that makes product and makes the world go around kind of thing. And then I started my career in the Defense Information Systems Agency, also. So right out of college, right into incident response, where I did incident response and like malware analysis for various entities within the Defense Department. And when I'm not spending time hunting for bad guys and trying to figure out what happened, I do like to do some stuff outside of work. So that's mountain biking, DIYing. I actually made a nightstand this week. And then cooking and eating that food. So without further ado, we'll jump into the juice of the presentation. So first things first, who is Fin11? Or they're known by many different names, depending on what vendor you're talking about. Mandiant calls this group Fin11. It's a financially motivated threat group that has been active since at least 2016. And publicly, a lot of entities will call them CLOP. They call themselves CLOP as well. So it's a little bit easier to, from like a PR perspective, I think, for press, for example, to say instead of some random number, CLOP, saying CLOP is easy. They are suspected to be Eastern Europe based for a variety of reasons, right? Various laws potentially make it a little bit easier to operate out of them. But one thing to note about these guys was that CLOP used to be primarily a ransomware deployment group, as well as getting like point of sale malware installed. So when they came up around that 2016, 2017, 18 mark, they would deploy malware, collect like credit card information, and then sell that on the black market potentially. But over the past couple of years, especially in the 2020s, they pretty much shifted to targeting specific server applications for exploitation and then performing that data theft and pretty much ransom or extortion. And a couple of high-profile vulnerabilities that they've exploited. So we have Exelion file transfer appliances, and as we go through these, you'll notice a pattern emerge in terms of what they like to target. Then they also did SolarWinds Secure FTP, also a file transfer application. Forta, Go Anywhere Managed File Transfer. Progress MOVEit Transfer, another managed file transfer solution. Clio MFT. So in this case, you'll see here an UNC with a 4-digit number. So in this case, UNC 5936. The way Mandiant tracks threat groups, we create threat clusters based on some sort of activity, and they usually get designated a number. So in this case, whoever did the activity for Clio MFT, they were categorized as UNC 5936. And then as we get more and more information, we might be able to tie that specific UNC to a bigger threat group. So in this case, these guys got tied to Fin11. And then finally, Oracle e-Business Suite. This was exploited between July and then publicly made in end of September. In this case, the threat cluster that did the exploitation was called 6493. And there's various overlaps in terms of like tools, techniques, how these clusters get bubbled up and tied to the main Fin11 cluster. So jumping into the first big exploitation, I actually worked this one back in, I think, 2023. So what is Progress MOVEit transfer? So this was a large file transfer application that was purchased by Progress. It was originally called Ipswich MOVEit DMZ, and it allows for secure collaboration for transferring files from one individual to a different individual, business to business, for example. Pretty much something similar to like Dropbox, Google Drive, OneDrive, but at a more secure kind of solution with more integrations. In the case of MOVEit, it allowed you to have multiple instances of this environment to do the file transfers as part of a single deployment. So if you deployed this application on a server, you can set up like buckets for individual like business units, for example, sub-organizations in your company as a way. And there was multiple ways as we were analyzing this application to actually interact with this app. You had your FTP, so standard open up, WinSCP and could transfer files that way. There's a web UI as well as a app API for more of that automated data transfers. What happened with this application is that in May 2023, CLOP was targeted it for mass exploitation, and they used several vulnerabilities against it to achieve their goal and then take the data from the systems. So one thing that was fun, when this happened, that was right around Memorial Day. So a lot of people were on holiday. And then when everybody came back from vacation or day off, that's when it hit the news and various organizations had to work a lot all of a sudden. So in terms of how we saw this exploitation, and this is something that will show up multiple times in the other cases, where the threat actor will actually research the application quite a lot and figure out the best way to achieve their root cause, usually getting remote code execution in this particular product. So in case of MOVEit, the whole exploit chain actually required 16 requests to a bunch of different places to deploy lemur loot. Lemur loot is what we ended up calling a web shell that the threat actor developed and deployed on this. So a couple of, for example, if you were wondering, hey, what were these endpoints that they used? So the first one, they started out with performing just regular access to this guest access.aspx page to allow them to generate a valid ASP.NET session ID. Using that session ID, then they were able to interact with other endpoints in case there's this MOVEit ASP.dll, which contained multiple vulnerabilities in it, including SQL injection, that the threat actor used to deploy their payload, elevate privileges, and then actually do additional cleanup to make sure it was harder for investigators to figure out what happened. And then finally, they used various API endpoints to actually trigger the vulnerability and then move around in the application. One fun fact, as we were doing these investigations and people were wondering, hey, why didn't it work in this case? We obviously see the attacker exploiting or attempting to exploit the application. If you had the web API disabled, for example, or not even licensed, the exploit will fail. And in the case of the tool that the attacker was using, it didn't handle that error gracefully, and it just continued trying to do the exploit. So a quick talk about lemur loot. So I mentioned the end goal of the thread of CLOP in this case was to drop lemur loot onto the MOVEit application. This was a C# web shell that was tailored specifically to this MOVEit transfer application. It used a lot of built-in functionality of MOVEit to be able to interact with its database, as well as where it stored files. And it stored a lot of the credentials to access this web shell, for example, were unique per exploit. So that way, the threat actor knew, this password only works at organization ABCD versus a different one. And also so that other entities, once this became public, wouldn't be able to use this web shell to access the server. It supported different functionality depending on what parameters it contained that was passed to the web shell, including full data enumeration, pulling back configuration settings. So in the case this MOVEit supported storing data inside Azure blobs. So an option that this web shell had is to export all the credentialing that was necessary to access those Azure blobs. You could create accounts, create fake admin sessions, or download specific files. And one unique thing about the way this web shell dropped, it wasn't like webshell.aspx, for example. It was called human2.aspx. And that was mainly so that it blended in with existing web pages for this application. There were legitimate pages in it called human2.esp. Human.esp. So if you were just looking at the web root and you saw human2, maybe it wouldn't have jumped out as potentially malicious. All right, so now how did that web shell get onto the box, for example? So the attacker used a pretty lightweight exploit payload that they managed to upload into the database. And then when a specially crafted request came in, that payload deserialized, and it tried to run this .NET code. If anybody has dabbled in .NET, this will look pretty lightweight. All it did was look for a specific header, and then took the data out of that header where the attacker passed in a string containing the actual web shell, and it replaced a string like change me lead with a randomly generated password, and then if it was successful, wrote it to disk. If not, replied back to the attacker saying, hey, I couldn't deploy the web shell. And we'll see this kind of logic too in the other investigations that we did in the products where the threat actors deploy various error handling to know to what point did they get in terms of the exploitation. Now, from a post-exploitation activity, what did we see with MOVEit? So data exfil occurred two different ways. So the first one was native functionality of the MOVEit application. In this case, the threat actor leveraged lemur loot, so the web shell, to impersonate a legit admin session or impersonate an admin, and then just regularly logged into the application as the fake admin kind of thing. And from there, they just clicked the checkbox to select all files, all folders in the web UI and hit the download button. So what you ended up with just like this ginormous zip archive getting downloaded from the application. If that didn't really work, in some cases, we did observe the attacker using the native functionality of lemur loot to download individual files. And that was just a bunch of web requests to the web shell with different IDs, for example, for the files that they were interested in downloading. All right, so that is pretty much it for MOVEit. The next big extortion event, max exploitation event that we're going to talk about is about Snowflake. One thing to note here, this was not done by CLOP or any of like CLOP affiliated groups. This was done by a different UNC that ended up getting called 5537. And this occurred a couple months after MOVEit in April, May of 2024. So this was last year. And what this exploitation did was they leveraged exposed credentials that were stolen by various info stealer malware. So VIDAR, Redline, there's a ton of different credential stealers out there. And that were sold or posted on the dark web. In this case, a lot of these accounts that were used for Snowflake exploitation, they didn't have multi-factor enabled. So, why do, you might be wondering, oh, multi-factor, why do I actually need to enable it on my like corporate accounts? Well, because, attackers will somehow get your credentials and use it. And if you don't have MFA enabled, that just makes it a little bit easier to log into your sensitive applications. As the teams were doing the investigation, some of the credentials were from the dark web monitoring that Mandiant does, were able to identify the credentials that were leaked. And what was crazy about some of them is they were stolen not like a couple of weeks ago. They were stolen over several years. And some of them have not been like rotated or even updated. So potentially a password that was stolen 2 years ago was still valid to be able to log into Snowflake. So you might be wondering, what is Snowflake? Snowflake is this kind of multi-cloud data warehousing platform. So pretty much allows you as the end user or an organization to upload all your like security telemetry, your business analytics, your sales stuff, data into it, and then be able to do various data processing on it. Various large, Fortune 500 organizations were impacted by this because they were storing data in this provider for their business analytics. One thing also to note with Snowflake was that a lot of the impacted instances that the teams analyzed, they didn't have like network allow lists in place, meaning that anybody from anywhere could access this SaaS product and interact with them. So as one thing from a hardening perspective, right? If once you guys go into potentially hardening or securing organizations, is that if a SaaS vendor allows you to have allow lists for what can access, enabling that does reduce your attack surface quite a bit. Now from the chain, how did this Snowflake compromise occur? It was a pretty straightforward compromise chain, unlike the 16 requests that required for the MOVEit compromise. Attacker gained credentials from info stealers, used those credentials, they built out their list of organizations that they wanted to target, and then just started trying to log into Snowflake with these stolen credentials. Once they actually got a working credential, depending on the permissions, they did a bunch of like database reconnaissance, storage reconnaissance of like what was in the Snowflake instance, and then they exfilled all the data that was stored. So this was either flat files, databases, stuff like that. So everything got downloaded to their infrastructure, and then they would send out emails to the victim organization saying, hey, we got your data, pay up or we'll somehow post it. And we saw some stuff get posted on the internet as a result of that. So this was a pretty like straightforward compromise chain. The next entity that we're going to talk about is actually Clio. Clio, they provide various integration software for either business to business or entities, as well as supply chain industries. So think about logistics, manufacturing, distribution. And they also build and develop various managed file transfer solutions. In the case of the Clio compromise that occurred in November, December of last year, so 2024, they targeted pretty much 3 different products. All 3 of them somehow related to the managed file transfer for moving data between enterprises, business to business, or just from end user to a MFT that the organization runs. In this case, they were targeted by 5936 UNC, which is an affiliate associated with CLOP through their TTPs. And they leveraged several vulnerabilities in these products to be able to execute remote code execution, to run their tools, upload their tools, or abuse this auto-run feature of the application to pretty much execute arbitrary commands on the server. And this worked even after the patch was originally applied. In terms of the Clio investigation, here we Mandate identified two different payloads. One was called Goldvein, other one Gold Tomb, and these will also be relevant in the Oracle investigations and exploitations that we saw this year. So Goldvein, this was just a regular downloader that was written in PowerShell. Pretty much this allowed the threat actor to download whatever their second stage payload. That way they didn't have to somehow get this big payload through the application and get it exploited. What was interesting about Goldvein was that it was a beacon that was that disguised itself as a TLS v3 handshake. And if you're wondering about what is TLS v3, no such thing actually exists. This was mainly just so that it would throw off, or potentially as a special string that validated on their end that, hey, we had successful exploitation. So once Goldvein was deployed on a system, it was used to download and then execute what was called a Gold Tomb stager. This is a jar file that then actually launched Gold Tomb. As you see, a lot of these names, they're just really made up. They don't really mean much, but it's kind of fun to track as what different actors use what tools. So Gold Tomb, this ended up being a multi-platform backdoor that was written in Java, and everybody's like, "Whoa, Java is an old language." No, attackers love to use Java, especially with a lot of enterprise applications. They're still written in Java, and yeah, they're a very easy to use language. So this was packaged into a jar, and then once it was loaded and executed on the system, it provided them various functionality. It supports both Windows and Linux OS, so having everything written in Java allows you to just reuse the same code for whether you're doing file access or interactions or downloads for pretty much on both Windows and Linux. And this was pretty much a full-staged backdoor with both command execution, interactive shell. It allowed them to navigate the file systems, as well as bulk download files packaged inside zip files. And in case of Clio, the CLOP affiliated group, I would say, they pretty much just did the same thing that we see this entity do, is find the data, leave the data, and then send those emails, extortion events, emails saying, "Hey, we did a proactive penetration test against your organization, and we had some findings, and we have all this data, so please pay us, or otherwise we'll release the data on the dark web, on their download portal." So that was pretty much Clio. Going to the next big event, and the most recent, this made actually headlines. There was various BBC articles, probably it made the news. So if you're an organization's C-suite, probably would have heard about this. So I also did several investigations in terms of Oracle e-business, and so you'll see me going a little bit more into details in terms of this, since I have firsthand knowledge of this. So what is Oracle e-business suite? A lot of people probably never heard of this product, but you may have used it as part of either College Live or then once you're in the business. So it is what's called an integrated business application, and it has a bunch of different functionality that's built into it. You got resource planning. So for example, doing all your different financials, tracking your payroll, human resources. That might be where you're storing all your employee data in there. You might be doing timesheet management in there. Then this thing also has customer relationship management, so CRM, where you're storing who are you, for example, selling to, or you're trying to sell, project management, business intelligence. So there's a bunch of different functionalities in there to make like the business operate and function. So this application was targeted by UNC 6493 in July and August of 2025 for that exploitation of multiple vulnerabilities. And as we were doing our investigations, we actually saw 2 exploit chains being thrown against this application. And then depending on how they worked, we actually talk about them here. So the first one, this one ended up being called the UI servlet exploit chain, specifically because the attacker was trying to exploit a specific URL that's called UI servlet in the application, and the activity for that one was tracked back to July of 2025. What was interesting about this exploit chain is that a exploit kit was actually leaked by scattered LastPass hunters. So they're UNC 6240. This was posted on, I believe, X or Twitter in early October 2025, saying, "Hey, look at this cool thing that is out there." However, based on like the investigative and analysis, Mandiant did not like observe successful or leveraging of this exploit kit, or it being used by UNC 6240. So potentially, what happened there is they somehow grabbed this kit from somewhere and then just published it to like make fun of somebody. This specific exploit chain leveraged multiple vulnerabilities also in Oracle EBS, and it performed things like I've listed here, like server-side request forgery, line feed injection. There was an authentication bypass. And then finally what it did was an XLSL template injection into the database, and then subsequent connection to that to be able to get a reverse shell going. And this was a classic bash reverse shell where a TCP socket was established outbound. If you're interested in learning more about this exploit chain, for example, Watchtower Labs performed a really good detailed analysis of this whole exploit chain, breaking down what every section of that exploit did and how it interacted with the Oracle EBS application. So moving a couple weeks later to August of 2025, here we see a new exploit chain being leveraged to actually successfully compromise the application and then take a bunch of data. This exploit chain starts with interactions to the sync servlet API, yet another API and endpoint in the application that the attacker then performed a bunch of different requests to it. I think, if I remember correctly, there was like 30 different requests that were executed to finally upload a malicious XML template into what Oracle calls the XDO template manager. This template manager functionality inside EBS allows you to have like pre-built reports, run some code, and then finally, the last functionality of the exploit chain was to call the preview function of the template to be able to probably either generate if it was a legitimate page, but in the case of the attacker, that actually executed the payload. And here we have a quick screenshot of how the exploit payload actually looked. And this was the same for both this exploit chain as well as the previous. So what Oracle allows you to store in its database and template is a XML style sheet that allows you to have pretty much Java code in it. So here we had a big old base 64 string that when this template was run, it would decode the base 64 and then execute whatever that Java code was. And in this case, the payload that we most often saw with these successful exploitations was something called Gold Vein Java. And this is a variant of Gold Vein that was originally seen in the Clio campaign, except it was converted to Java. And this downloader pretty much reached back out to attacker-controlled infrastructure. So a web server was doing outbound network connectivity and downloaded whatever the second stage payload was. In this case, this beacon or outbound connection was disguised as a TLS v3.1 handshake. So again, slightly similar, but slightly different to that original Goldvein PowerShell script. And it also contained custom logging functionality that responded back to the whoever was running the exploit, whether or not it was a successful exploitation. Otherwise, it would store various error logs to say where exactly did it fail. The second stage, unfortunately, we were not able to recover, but it appears to have been a pretty robust tool that allowed the attacker to do a lot of different functionality in the application. So, for example, when this Goldvein Java payload was executed and it didn't succeed in successfully running on the system, or outbound connectivity was blocked, the threat actor deployed a different payload into Oracle EBS. In this case, we called it SageGift. So SageGift was actually a chain of multiple Java payloads that were stored inside each other that established a persistent filter in Apache that monitored requests to these two endpoints. Both were navset help. And what a persistent filter allows a developer to do is pretty much that. Filter incoming requests, and if they match certain criteria, then execute some sort of code. In this instance, it acted more of a classic web shell where we saw what we suspected was attacker loading some sort of additional payload into memory, and then a ton of different web requests to these endpoints that returned various amounts of data. And as I mentioned, unfortunately, the second stage malware payload was not recovered in both instances, as all these payloads were ran in memory, and nothing got pretty much written to disks besides the original template that was used for the exploitation. And if you look at the diagram over here, you actually can see all the different types of malicious code that was part of SageGift. So you had SageLift that installed the filter, and then SageWave that actually did the filtering with various authentication capabilities in there to make sure that only malicious actors were interacting with it. So once your Oracle EBS application was all compromised, what did this threat actor do? They ended up running a bunch of various system enumeration commands. They listed out what kind of disks you had attached to the system, listed what is your IP info, for example, host name, very basic enumeration commands. And then once they were done with it, they just started leveraging the payloads to download files from the mounted disks. So this could have been anything that this application had access to. And in some cases, these applications were configured with various network shares that stored terabytes of data. And what we saw in some of the investigations was that terabytes of data were leaving the client's environment and getting uploaded to threat actor controlled infrastructure. And then threat actor ended up ransoming, sending those extortion emails saying, hey, we did a proactive test. We have all your data. Please pay us money or it'll get posted on the internet, which happened to a lot of organizations. So in addition to actually files leaving the network, what the threat actor managed to also do is export various tables that were used by the Oracle e-business suite and stored in their database. And those tables are what potentially contain a lot of the more sensitive data. So if you, for example, had all your employee information stored in the database or in this application, you might have had social security numbers in there, credit card information if there was, if you were handling some sort like sales, you might have had banking route information. So these applications themselves, they potentially contain a lot of sensitive data as part of businesses. And this explains why at least Club likes to target them for that exploitation and data theft. All right, so we looked at several products that were exploited, some campaigns that we saw in terms of exploitation and then that mass extortion event. And you might be asking, well, how can you protect an organization running some sort of product, right? Well, couple things. First things first, enabling multi-factor authentication. This is probably the big thing for anybody nowadays. Make sure you have multi-factor enabled on all your identities, logins. If there's some custom thing that you're using, make sure that's protected by multi-factor. It makes it just that more difficult for somebody to compromise credentials and then to log into the application. Additionally, with these products that we see, a couple of them, and the ones that have been exploited historically, organizations stored a lot of old sensitive data in these programs, and a lot of these applications had built-in functionality to automatically delete files. So if your retention, your organizational retention is, for example, 90 days, then these MFTs should be configured with automatic file deletions. That way you don't have these strangler data files sitting there for years or years that might contain sensitive data, which just limits, again, the amount of data that gets potentially exposed. And as we saw in terms of MOVEit, right, where that if your web API was disabled or not licensed, nothing happened. If you are deploying an application and it is going to be publicly accessible, disable all the unneeded features. A lot of these enterprise applications come with a bunch of functionalities that is potentially enabled by default, and you may not actually use, or your organization might not need them. Remove it, disable it, or block it so that that attack surface, yet again, is reduced a little bit. And then one big thing that we definitely recommend, both as a result of this and just in general, is deploying some sort of web application firewall instead in front of any public websites. As soon as you put a public website up on the internet, I bet you within 5 minutes, it's going to get scanned by some automated tool out there, whether it's some sort of organization doing proactive security monitoring or threat actors seeing what's out there and what can be exploited. Having a WAF will block some stuff, right? It's not going to block everything, but it will block majority of malicious activity. But the other benefits of a WAF is that we will be logging a lot of those requests. So should the application get exploited, you'll have some sort of additional logs to be able to investigate. And then finally, this is applicable to .NET in particular, but both Java and PHP have similar functionality. In .NET, do not use the binary formatter if you are a developer. This is what led to the exploitation of the MOVEit application. They used the binary formatter, and the attacker was just able to upload a malicious .NET thing, and that was allowed to be executed. Microsoft, so this warning is actually directly from Microsoft's documentation. Right on the top of their page, they say, do not use it, and then they provide documentation on how to use it. So if you are really risky, use it and hope you don't get exploited. And then, as I mentioned, Java and PHP, they all have these ways to execute these gadgets that are stored via binary formatters. So these are recommendations from hardening. In terms of detections, from a detections perspective, there's multiple ways to see, before you get that email from the threat actor saying, hey, we got all your data, pay us money. You can have an alert set up to monitor any new file creations in web routes. Right, so this will both work for these mass exploitation campaigns as well as a threat actor that specifically targets your website because there's some sort of vulnerability in it. This will help you detect if a web shell gets dropped, and potentially allows you to, early on say, hey, web shell or some weird file got created, we need to investigate, and this will allow you that extra time to block the attacker from doing more harm to your environment. Additionally, deploying an EDR solution to your key assets, right? As organizations get more and more EDR, a lot of times, for whatever reason, they don't want to deploy EDRs onto Linux servers, which a lot of these products run on. But an EDR would give you additional telemetry about what is happening, as well as potentially block the malicious activity from further running, or at least give you that, again, heads up. And as you're building potentially alerts for your new EDR, develop detections. These two detections, like monitoring for outbound connections from web servers or unexpected processes, this would have potentially alerted defenders for a lot of these incidents, but also for any other incidents where a web application gets exploited. And then finally, also monitoring for web servers launching weird processes. So for example, your web server shouldn't really be launching like PowerShell.exe or CMD.exe. If that is happening, something to potentially alert on and then action. And then finally, this is a big thing that a lot of organizations still struggle with, is to forward application, and I'll say both security logs too, to some sort of log aggregator SIM. This allows you to do enrichment as well as create alerts. So alerts that would have helped in the cases of these applications. And we saw the logs actually generated by the application. So generating, hey, a user logged out, but was never logged in. That is a very weird edge case that you might want to investigate. Additionally, spike in downloads. You can pull those logs from any of those MFTs, as well as any SaaS providers that are out there that store logs or you store data in. Look at that logs and then, hey, why is, for example, Bob123 downloading 100,000 files when this guy never downloaded any files? That would be an investigative thread that you could start pulling. And then also, similar to what a lot of email providers have, that impossible travel detection. And having an impossible travel for any admin access to these applications would help with having that early on action. One thing in terms of, I know I talked a little bit about WAFs as well as forwarding logs to a SIM. One thing that a lot of times gets forgotten with web logs, web applications, and just pooling logs is this X forwarded for header. So when you are working on getting your logs collected from various applications, web servers, making sure that any web server that is sitting behind a web application firewall load balancer has this X forwarded for header enabled, both on the web server as well as any upstream network devices. What this header allows the application to do is to log the originating IP address of the client performing the interaction. So, for example, if I were to access, let's say, google.com, and google.com is not behind any WAF or load balancer, the web server would log my IP in its logs. Now, you put that website behind a WAF in this case, and if you don't have this for header enabled, then what the web server would log would be just the IP of the web load balancer or the WAF, making an investigation a lot harder if both places don't store logs or somehow the IPs don't match up. So the pros here are, you will have that originating IP. And what's interesting about the X forwarded for header, it will actually track every single instance of your request as it goes through all these different appliances. So you might end up having a nice long value that is stored in that field that is comma separated. And the downside of this is, unfortunately, actually, the event size is going to increase because you're storing a little bit all that data. So these are a couple of great detections that, if were implemented in organizations, would have given them that heads up of an attacker exploiting their appliances. And then one final thought that I want to leave everybody with is something called the collection management framework. So this is more from a getting ready before an incident kind of thing that you would do. So collection management framework is pretty much a listing of all the different applications, tools, technologies that you might have inside an organization from which logs can be gathered. So this is gathered for either incident response or, in the proactive sense, for threat hunting, so that the security team can be like, hey, I'm interested in looking at this. What logs can I do? This is actually going to be a living document that is getting continuously updated as new business needs arise, new technology. Hey, you just deployed this product, this VPN solution, what kind of logs are getting collected on it? Having that identification is important. That way, should an incident occur, and most likely an incident will occur at some point, the incident response team isn't scrambling trying to figure out, hey, where are logs stored? Are they actually stored? So with this collection management framework, you can answer various questions. And in the next slide, I'll show a really basic example. But this document will tell you potentially, what data do you have? Where is it stored? Are the fields normalized? A lot of logs are in very arbitrary formats, and unless you normalize it, you're going to be looking at source IP in one instance, source underscore IP, SRC IP, and just trying to mash all that together when everything's on fire and the business is not operating makes it a little more stressful. In this document, you can also identify how long is data stored for. I can't tell how many times we go into an incident and the organization says, yes, we are storing data for 90 days. And then as soon as you connect to their SIM, it's only for 7 days for the important data set, and it's not the 90 that they expected. And then finally, this is for, as you start maturing from a security perspective, you can identify what kind of MITRE attack coverage, for example, the logs provide. And you can build out this nice diagram saying, hey, we have really good coverage of process execution. But persistence, we might have, with the logs that we might have trouble detecting persistence. So having this collection management framework mapped to MITRE will give you an overview of your security posture, and as well as make threat hunting a little bit easier. So as promised, here is a very basic template of a collection framework, management framework that can be created. So you would break down this table based on the type of asset that is in the environment, the type of logs that are generated, and then for each of these, the assets that you have. So let's take example, VPN servers. The VPN server will be storing VPN session creation and termination access logs. And then you can identify which MITRE attacks or techniques are covered by this. So in this case, this is very high level. You've got your initial access and exfiltration categories. But if you want to be really more specific, you can go into the exact specific TTPs here, map it all out, and you'll have your threat intel team, your threat hunters, your incident responders will forever love you if you have something like that. And then also identifying how long your data retention is. Here you can even subcategorize it. Hey, we're storing 30 days of logs on the actual appliance, and then data is actually also forwarded to our syslog server. And on our syslog server, we might have 180 days of data retention. So this, just having all this broken apart gives you that nice visibility into your logging infrastructure. And then finally, as a last thing, you can have a category of what other logs do you want to collect from this specific device, having that identified so that you can plan your future development from your security stack. And then the final slide that I'll leave everybody with is some additional reading. So if you want to read into a lot of these campaigns that we talked about, I have a couple of blog posts from both Google Mandiant that are published, as well as some other third-party entities that have really good write-ups about the events. And then if you really want to read about why the binary formatter in .NET is bad, there's a link from Microsoft that talks about how to not implement a binary formatter and why you should not do it. So with that gets me to the end of the deck. Thank you, everybody. And now I'll take questions if anybody has any questions.
First of all, thanks a lot, Peter, for a really interesting talk. Yeah, so I guess maybe while questions are coming, just wanted to get your thoughts. So you pick really excellent examples and talk to us about those. If you look at from the more statistical perspective, is it, as you see, that multi-factor itself can actually save quite a lot? So is it that are we seeing the number of attacks reduce and their patterns are very restricted fashion where they indeed go after the credentials most of the time? So what is so the attack that we saw in 2000s are quite different from the attack that we see now if we look from what you see, right? So if you look in recently, what trend do you observe here from the example that you consider as well as in general more example that you have studied?
Yeah, so in this case, these were all server-based applications that they were targeting. A lot of the stuff that you think about, like that happened in the 2010s, where somebody goes downloads something and they get compromised. Oh, you see that all the time still. Like we just worked an incident where somebody downloaded some third-party tool that they thought was the tool that they were downloading, and it came with a backdoor built into it. So that allowed the attacker pretty much instantaneous access to their domain admin credits. So the end user is still that weak point, and a lot of times that will be probably the most times how an application gets like an environment gets compromised. MFA is great until you get to an attacker controlled login page that prompts you for an MFA, and you type in your your 6-digit PIN, and the attacker logs that, steals your session cookie, and you are still logged into, for example, Google Workspace, Microsoft, but your credentials are stolen, and the attacker can use that then. So we do. If anybody wants to read about trends and stuff, Mandiant puts out a annual survey or document about all the different attacks that we saw of the previous year. That should be coming up for 2025 here in the next couple months. But a lot of vendors do the same kind of posts about what they see in terms of trends. And I would say it's a very cyclical pattern where this one thing works and everybody jumps onto it, and then all of a sudden, some one thing and nobody's doing it, and everybody's trying to do something else.
Okay. I do have a question, but I'll see if there's some other questions.
You were the only one with questions, so go right ahead.
Yeah. So I'm just trying to check if there's some other students who want to ask questions. So from the detection perspective, the false positive is certainly is something to. I mean, all detection mechanisms that you mentioned about, there will be false positive, right? So, is it just like, is that in your experience, do you find that to be a significant challenge, or you see it's a necessary evil, so everybody has accepted that fact and work with it?
Yeah, so a lot of the times you can reduce the amount of false positives, right? So for example, let's take the detection that I was talking about, a web server launching processes. So in this case, this could be your IIS process, Apache, Tomcat, PHP. In theory, that should not really happen, but developers will be developers and they'll do some janky stuff. So as you're developing these detections, you can start out with a default, hey, web server launching a shell, PowerShell, CMD, yada, yada, yada. And then you can start accepting that. If you know that you have an application that is known to do that, you can filter out specific stuff that it would be doing versus just completely filtering it out, because what happens if that does get compromised? And you can use that as a way to tell your developers, hey, stop doing that. That is not best practice, for example. Use native functionality, or don't launch cmd.exe to get the host name of the host, for example. That's silly to do.
All right. I don't think there are any more questions, and we're already over the time. So I guess probably we can thank you, Peter, and
Thank you.
yeah, thanks a lot for a very interesting talk. And I guess hopefully you get opportunity to visit Purdue sometime in person.
Absolutely. Yeah, maybe next year, next seminar.
Yeah, that'd be great. Great. Thanks a lot, Peter.
Yeah,
Appreciate
thanks,
it.
Pete. Have a great holiday.
Yep. Happy holidays. Take care.
Bye.
Bye.